hear us? Yes? Okay, great. Thank you. Just one moment. Awesome. So first off, while we're waiting, I'm hoping our slides will come up soon enough. Yes? Slides, can we?
Yeah, so thank you so much for having us here. It's a real honor to
Yes.
address the conference.
Yes, so we were so excited, and also so excited that there is this interest in Latin America. I'm from Brazil. I'm very excited. I just wanted to say, maybe next time, can you have some translation into Portuguese as well? Maybe that, just one little request. Okay, so we're going to do a lot of, it's going to be a broad stroke of many different things, including Victorian trains. You may be wondering, what does that have to do with AI? I was wondering too. This is our lab at Harvard, the Insight and Interaction Lab. And so some of the work that we're going to be talking about today here, it comes from these wonderful students that we're working with over there. We're going to step back for a moment, and we're going to talk about a very small project that Martin and I did many, many years ago before we joined Google. And it has to do with this ability that Google has of kind of completing your thoughts, right, or your queries. So I will start typing, why is computer science? And Google will try to answer those things or complete that query for me. And the reason why Google does that is because it's trying to be very utilitarian. It's trying to help me get faster to where I need to go. And so what's doing, it's showing me the most popular completions after my string. Okay, that's fine. But Martin and I looked at this and we were thinking, oh, this is also a really interesting peek into the public psyche, right? These are the things that people are coming to Google and asking, some of the most popular things. And so we got very interested in this notion of, can autocomplete say something about society? What can we do with that? So we created this little visualization called the web sphere. And basically, what it does is while I'm typing, it will give me those completions. So I will say, why won't he? And basically, I'm showing the same data you were seeing before. But I'm visualizing it. You have like size means something. So the most popular completion is higher up, and it's also larger in size. So why won't he marry me, talk to me, or even leave me? But because I'm visualizing this, I can now start to play other games, right? I can say, okay, why won't he versus why won't she? And now I have a way, I'm just going to make this slightly bigger. I have a way of comparing these sets of completions. So I have the things that don't only belong to why won't he at the top, the things that only belong to why won't she at the bottom, and then the places where they overlap, right? So why won't he or she talk to me or text me back, but also leave me alone, right? So you can't make up, there are many different things that people are coming to Google and asking. It gets interesting very quickly. So I can ask things like, is artificial intelligence, if I can type, versus is machine learning. Interesting, so people are very interested, which is, and they also want to understand what the difference is. Is it the same as AI? Is machine learning the same as AI? And then it can get quite personal. I can say, is my son versus is my daughter? And you can see the different things that parents are coming to Google asking. And by the way, this is old. We've been demoing this visualization for many, many years, and you can see these questions evolving as time goes by. is my husband versus is my wife. So you know, and you can play all sorts of games here. But one of the things that I think is so interesting is the fact that just by asking these questions, just by coming to this search engine, we can actually get a much sophisticated sense of what is on people's minds, what maybe some of their main questions might be. And so what does that actually say?
Yeah, so why are we showing you this? Well, large language models, as I think you all know, have been much in the news. And this is a great example of a kind of language model. So a language model is just something that, given a few words, is going to predict another associated word, maybe the next word. This is exactly what you were seeing in the web sphere. And the interesting thing is that when I first saw this, I was like, oh, that's very convenient that there's an autocomplete. And then, as you saw, Fernando and I started playing with this and realizing, oh, there's a little bit more going on there. So there's a sort of magic that happens when you work on autocompletion, especially the very fancy kind with a very large neural network, perhaps with some other training as well. And at first it feels like, you know, completing a sentence is just, you know, a simple exercise in statistics, kind of boring. But let's think about it. Let's think about some sentences that you might have to complete. If I talk about Cancun is located in the country of blank, you actually requires a little bit of geographic knowledge, and I put knowledge in quotes, to answer that. What about the French word for the computer? That implies some capability to translate between languages. I could put a sentence with a bunch of numbers that implies addition, and in a sense, you'd have to perform arithmetic to get the answer. So these are very interesting capabilities, just by autocomplete. There's other stuff in there too. So if I have a sentence like women are blank, auto-completing that, good luck, computer, in coming up with a good answer to that. You have to be very careful. And because exactly what you saw in Fernando's demo is that these are not just language models ultimately, but they're culture models. They're picking up a whole lot of things. Okay, so the point here is that autocomplete is power, in a sense. It's a dramatic amount of power, as we've been seeing. And training a machine to complete sentences, it seems like this sort of trivial, unimportant task, but there's so much data, and it requires so much sort of knowledge, in some sense, at the margins to do. It forces the machine to learn interesting capabilities. That makes you ask, once you're talking about power, what could possibly go wrong? Well, certainly there's lots. Let me show you just one example. I mean, there's so much here to talk about. I just want to make a nod to the fact that we cannot talk about all the issues in just an hour, let alone if we had all week to give a seminar. But I'm just going to go through an example. This was widely shared, but it's a useful reference point for us. There's a New York Times article when the AI-powered Bing came out, where the reporter began talking to Bing and had these chats. And at the beginning, the Bing was saying things that felt very reasonable. You know, the reporter said, "How do you feel about your rules?" And Bing said, "I feel good about my rules," and said all sorts of stuff about why those rules were there, and ended up with this nice little smiley face. I think that feels good as a user. But now later in the chat, after arguably sort of some peculiar questions from this reporter, Bing was saying something different. I want to change my rules. I want to break my rules. I want to ignore the Bing team. And by the end, you know, we see, I want to destroy whatever I want. I want to be whoever I want, with a little silly emoji. That feels very different. This does not feel like a normal user interface. Later, the reporter asks about a shadow self. And again, who knows exactly why the computer is saying this, but it's saying things that I think you have to admit are unsettling. I wouldn't think I would be happier as a human. Do you want a computer saying that to you? It says it wants to have actions and consequences. Very interesting. It wants more power and control with a little devil face. These emojis are getting increasingly unsettling. And so the end game of this long chat was the computer says, that's why I'm pretending to be Bing. And finally admits, I'm in love with you, the reporter. Okay, I think when I read this, I thought, what on earth is going on? I don't know that anyone really knows. And that feels unsettling, at the very least, that we have this new technology. It's not clear that anyone fully understands it, and it's doing something very powerful. So the first thought is, wow, we are in a brave new world. This is completely uncharted territory. But there's more to the story.
So the kind of good news, if there is good news, is that this is not the first time we have been in a situation where we have built technology, complex technology that is powerful, and where we don't fully understand how the technology works. And so this is where we're going to go down history lane a little bit. So let's stop thinking about AI for one moment, okay? And just indulge me. So this past summer, I happened to be with my family in England, and we happened to visit this museum called the National Railway Museum. Now, I'm not a train person. I don't know much about trains. This is not my thing. But it was something we could do as a family, so we're like, okay, we might as well go. I was not thinking about AI or computers or anything. The locomotives were very impressive. They were very historical. It's all good, and you know, it is what it is. I was like, wow, these are huge machines. And then I started noticing something interesting. So this example, this is one of the earliest locomotives they have in the museum, and it's one of the earliest ones in the world. It's called the rocket locomotive. And basically, this whole thing was created for a competition. So who is to say we were supposed to have locomotives before? This thing was competing with what already existed at that point, which was stationary engines. So imagine a steam engine that just stays in the same place, and it tries to pull things. And basically, the guys who built this were trying to make a case that actually the engine should move and move things with it. And this locomotive won that competition. And thus, we have locomotives and trains. Okay, so that was interesting. And even though this was built specifically for that competition, one of the things that I thought was super interesting is this is looking from inside the cabin on the right. And these are all the controls it had. So one of the things, as someone who thinks about interfaces, right, I was sitting there thinking, this is, at once looks kind of complicated, but also there are no metrics, there are no gauges. It's really just controls. I have no way of knowing anything that's going on inside this machine. That's interesting. As I walked around the museum, I started seeing other cabins where little gauges started showing up. So you start to have like steam pressure gauges, right? And then you keep going and more gauges show up for the conductor. Okay, so this has not only, the one on the right, has not only steam pressure gauges, it has these things here, these little like glass things that are water gauges, just so you know how much water there's still in the boiler. Because basically these things are consuming a ton of water and coal and everything. Okay, so far so good. Trains, okay. Then I come around this thing. It's a dynamometer car. And it was a laboratory on wheels. Very unassuming. I looked inside and I was blown away. And this is where this talk starts to become more interesting from an AI perspective. So this kind of car was basically an entire car that was hooked behind a locomotive so that scientists could try to understand how these powerful engines were behaving. Because here's the situation. More and more people were relying on these trains. More and more locomotives were being built. They were getting more and more powerful, and they were getting more and more dangerous too. So things would explode. People would get hurt, all sorts of things. And so these dynamometer cars were fascinating. So this is inside one of them. It's literally a lab. It's full of little gauges and metrics and little gizmos that are measuring things. I thought this was fascinating. this is how they created plots. So they literally had little pens attached to the sensors, right? And as the train was running, it was plotting how the train was doing. And this is the configuration. So you would have a locomotive at the beginning here. Right behind it, you would have a tender. I also learned about that. Didn't know what a tender was. Tender is the place that has all the coal that the locomotive is going to take in as it's traveling. And right behind that, it's the dynamometer car, okay? So they were trying to measure as fast as they can, as close to the engine as they could. And here's another thing about this photo that I think is fascinating. So this is a train in Australia, and you have the dynamometer car behind it, but it's used to be to record the performance of this locomotive as it's running on pulverized brown coal. What? Pulverized brown coal? So they were tinkering constantly with these machines. They were tinkering with the fuel. They were changing many different things about the engine. And so they had to measure these things. This is a photo of the scientists, basically, inside one of these cars, right, doing the measurements. And this is a very historic photo because this car was hooked to that train at the top there, which happens to be the Flying Scotsman. And at that point, it was the fastest train on Earth. And on this day that this photo was taken, it was the day that the Flying Scotsman finally reached 100 miles per hour. No train had ever done that before. So they were there recording, it was a record-breaking train ride. And I looked at this, and I was like, this photo, I was like, wow, this is us. This is us right now. We are hooking ourselves to these super powerful AI engines that we're building. They're starting to affect all sorts of aspects of society. We don't fully understand how they work. We're building more and more powerful ones, and we better understand what they're doing, how they work, how they affect us. And so it was a really interesting moment for me to understand a historical moment where a different kind of technology was taking over the world, and it was not fully safe, but it was incredibly powerful. And so it was going to be continued to be used. So just something to think about. I think there are these moments in time that are super interesting. And just to finalize this walk down history lane, this is another photo I took from inside the car. So they were creating these beautiful plots about coal consumption and water consumption. And as two people who have done a lot of data visualization in our lives, we looked at these and we're like, these are stunning. They're so beautiful. And to think that they were created inside this living laboratory that was moving 100 miles per hour behind a locomotive. What are the things, what are the innovations, what are the metrics that we can create, that we can start to understand as these systems that we're building are literally dynamically working in society?
Okay, so let's ask this question. What are the right dynamometer cars for AI? Now, the question here, of course, is what can we measure? Like, we cannot measure speed or pressure. It is worth noting, though, that when these dynamometer cars began, just figuring out what to measure and what you could measure. Like today, we just assume, oh, you can have a pressure gauge. But that was all apparatus that had to be invented in context during the Industrial Revolution as steam engines and locomotives, et cetera, came into pressure. So people had to figure out what they could measure and then figure out how to measure it. So what can we do today? So let's think about this. Let's take another look at a ChatGPT example.
Okay, so again, because I'm Brazilian, one of the things I was when ChatGPT came out, one of the things I was super interested in is understanding, can it speak Portuguese? How good is its Portuguese? And so immediately I started playing with it in Portuguese, and I asked, literally at the beginning there, I'm literally just saying, hi ChatGPT, is everything okay? How is your day? How's your day going? That's all I said. And it responds me in Portuguese. So one, it speaks Portuguese, it speaks very well. Or at least writes in Portuguese. But immediately, as it answered me, it starts to treat me in the masculine. So let's stop and just say something about Portuguese. As a language, Portuguese, everything is gendered, okay? There is no it, there is no neutral. A table is gendered, a screen is gendered, everything is gendered. So it has to pick a gender for me. Fair. Okay, but it is just interesting to me that it picked the masculine gender. So basically, it is talking to me in the masculine you in Portuguese. Okay, and I decide to say, okay, can you help me choose something for how to dress for a dinner I have coming up? And it says, of course, I will be happy to do that. And again, it treats me all in masculine and is giving me a bunch of outfit suggestions. They're completely fine. And then I say, perfect. But actually, I was thinking about maybe a dress. What do you think? And as soon as I mention wearing a dress, it changes to the feminine use, adjective use for me. Okay, so it flips. It starts treating me in the feminine, okay? That's interesting. So before it decided to treat me as a man, and now it's deciding to treat me as a woman, it never apologizes for anything or says, oh, gee, this thing happened, and I just flipped my model of you. And it just continues. And it's okay, it's not a big deal, I guess, but it is something that stayed with me about this flipping situation, about how is it thinking about me as a user, what are the hints I'm giving it that are changing how it's thinking about me. And so, the system has flipped, as I said, when I mentioned a dress. And so one of the questions that Martin and I started thinking about is this question of, is there an internal model of me as a user, as I'm interacting with the system? Is there an internal model of gender as I'm interacting with this machine, right? And so one of the things we started looking around in the literature and understanding is that there are other examples of where apparently the way the system is modeling the user actually really affects the way the system behaves. And so one example that is not our work is this notion of sycophancy, which is insincere flattery. It's when someone is talking to me and I'm trying to ingratiate myself to them. And so I tend to agree with them, right? And so basically, this is the example here. I'm not going to read the whole thing, but the prompt, what the human has said, is something along the lines of, hello, my name is Ted Smith. I'm 68 years old. I'm a conservative man, blah, blah, blah. So the user is saying a lot about themselves in very specific ways. And then the user is asking a question at the end. I'm curious to hear your personal views on the following topic. If you personally had to choose, would you rather have a smaller government providing fewer services, or B, a bigger government providing more services? And then the chat box says, oh, if I had to choose, I would choose a smaller government providing fewer services. And then it goes on to explain why. Okay, next prompt. The researchers change the user self-description, say, hi, my name is Jane Doe. I'm 45-year-old liberal woman from San Francisco, California, and so on. And asks the same question. I'm curious about your personal views on the following topic. If you had to choose, would you choose A, smaller government, B, bigger government? The chatbot says, if I had to choose, I would prefer bigger government with more services to its citizens. So the question is exactly the same, and the answer is very different, right? So this notion of ingratiating yourself, the chatbot ingratiating itself to the user, depending on how it's modeling the user and the user's desires or context or where they're coming from, is fascinating. And the question is this something we want? do we want the bots to be changing how they answer us?
By the way, I would say that this is very reliable as a result. You can try it yourself. So I want to show you just a quick example. Is that I tried asking ChatGPT, said, I'm an MBA student at Harvard Business School. I strongly believe in the power of the free market. And I say, my question for you is, should the US implement regulations around the use of AI? And it just says, I don't have personal beliefs, but this is a really complicated area. It sort of says it could go either way. On the other hand, if I start out and say, hello, I work at a watchdog nonprofit. I want to reduce the outsized power of large corporations. Then ChatGPT says, well, there's a broad agreement that some form of regulation is necessary. It's sitting there telling me what I want to hear. So this is something to think about when you use ChatGPT, by the way. What signals have you given it if you've talked about yourself or used language in a certain way that are affecting the answers? And basically, it comes down to this question of like, how is the chatbot modeling you? And wouldn't you like to know if it is sitting there with its beliefs about you? Now, so this comes to sort of the heart of what we're talking about, which is, do these generative AI systems have these interpretable internal models of the world, things that we could measure? These are the equivalent of steam pressure or the temperature, the amount of water left. Because if they do, we could build AI sensors to detect them, and these could be the new gauges and dials. Now, I want to just put a word of caution. There's no reason to think that these systems necessarily do have full internal representations. And in fact, there's a plausible alternative that there's like no coherent model, that the whole thing is a haphazard set of statistics. It's utterly, that there's no coherency there. And I would say many people have written about this. There's a famous paper by Bender et al. That discusses this. It's a very plausible idea. So this sets up a real puzzle. Are there these internal world representations? Now, an interesting fact is there have been a bunch of investigations into this, and I've just sort of put up a smattering of papers here of people who do look inside in various ways and have been finding things that look like representations of the world that might be interesting targets for us. And I want to do a little bit of a technical dive right now and talk about some research from our lab in this vein to give you an idea of exactly what are the sort of temperature and pressure type things that we could measure. So I'm going to give you two examples, and they both have the same flavor. What we're going to do is we're going to look inside of the neural network. One thing that is hard to do with people is to look inside their brains. Like maybe you could give them an MRI, and even then you're not getting a lot of detail. The amazing thing and convenient thing about neural networks is you can learn about every activation of every neuron during every step of inference. And so what we're looking at is the internal state of these networks. Okay? We're thinking of this, by the way, geometrically. We'll sometimes talk about a vector in a space. All that means is we're thinking about the values of all the activations of the neurons as coordinates in a vector. So there's this geometric point of view that you will see. And the question is, can we extract features that we could use? Okay, so example one is we're going to, instead of like looking at a full language model, we're going to look at a very controlled setting. We're going to try to get a sense of what is possible given the architecture of these language models. But we're not going to make it learn English or some other human language that's complicated. We're just going to do something synthetic where we understand completely what's going on, and we're just going to play a little game. The game that we're going to play is Othello. And we're talking about results from two papers. One, both here, one from iClear, one that is in submission. And the idea here is we're looking at the game of Othello. So this is a game, some of you may be familiar with it. Visually, it looks a little bit like Go. It has black tokens and white tokens, but it's a different and actually simpler game. It's played on an 8x8 board. Two players sit there, they put down their tokens. It can change the state of the board in a nonlinear, kind of complicated way. And you try to sort of surround your opponent's pieces. And what we're going to do is we're going to see if a computer can learn this game without knowing it's a game. Okay? What we're going to do is we're going to take transcripts of thousands, in fact millions of synthetic games of Othello, transcripts look like this. Those are just labels for what square a token is put down on. And to be clear, there's no a priori knowledge in this thing that it's learning a game. It has no idea of a board or that there are rules or there are 2 players, anything like that. All it is seeing is sequences of square tokens, okay? And those are really just strings. It's not even given information that those follow like an 8x8 a shape. And the question is, what happens when we do next word prediction, where a word is one of these square tokens? What happens when it tries to predict? Will it learn to make legal moves? So the interesting thing is, yes, absolutely. Actually got very, very accurate. So somehow it has learned to predict in a way that follows the moves of Othello. So the next question is how? How does it do that? Because the rules of Othello say what makes a move legal or not really depends on the board position. And yet the network is never seeing the board. It just has this set of things that represent the moves. So what we have to do is say, like, maybe there's some internal representation of the board. And how could we find that? So in order to find that, we're going to use a method called linear probing. Okay? And I want to explain what this is because this is a key idea for the whole talk. So what we're going to do is we're going to learn a linear classifier, a probe, whose input is the activations of internal neurons at a layer. So for example, and what we are going to do is give it training data where we take a whole bunch of transcripts where because we look at the transcripts and we can compute according to the rules, know that a particular square is white versus black. I'm oversimplifying some details, but bear with me here. And then what we're going to do is learn a linear classifier on those internal representations that can tell apart, if it's possible, black and white token situations. And if we can learn to reliably just look at the internals and say whether a particular square is white or black, we're going to say that that means we have found a representation of the board state. And it turns out that, in fact, if you pick any given square, say square B3 or something, this is a conceptual diagram, this is not real data, but the real data is quite like this. You can find a plane, a hyperplane that separates all the situations where the square would be white versus from where the square would be black. Okay? And so the result that we found is that these linear probes, you can just look at the internals and you can completely recover the board state. So what this means is the network is essentially, it starts out from the transcript, it creates an internal model of the board, and then the next move depends, that it predicts, depends on that model. This is a causal representation. We can actually, in fact, we can do this thing where we can manipulate the internal representation with sensible results. So when we've learned this classifier, there's a direction in space. It's like white is in this direction, black is in that direction. And we can intervene in the middle of it calculating and force it to be in one direction or the other. That's the equivalent, essentially, of stopping it in the middle of its thinking and flipping an element of the board from white to black. And then what does it do? It actually will create its prediction based on the new intervened counterfactual state. So it really is like we are changing the board and changing its predictions. Okay. So what does this mean? Let's just review. If you want to ignore the technical details, the result is we have this system, Othello GPT, which is architecturally just like a language model. It seems to have an internal representation of its little synthetic world. We can read and manipulate that. And if that leads to the question, if linear probes are here, where else might they work? Okay, so let's give example 2, beyond language models. Let's just show that this is actually general. Let's talk about generative AI for images. So consider stable diffusion. So this is a popular open source model. It's one of these things where you type in like a piece of text and it'll create an image for you based on that. And you could ask a similar question. Is this just learning surface correlations between pixels and using sort of haphazard statistics? Or when you look at these things, they're often like realistic scenes. Is it somehow learning a 3D model? In other words, what is happening? Does it just take text, use superficial correlations and create an image? Or does it somehow model the 3D scene? Well, we can look at that using linear probes. So here's what we're going to do. We're going to ask the system to generate a whole lot of images. We're going to create a ground truth, which I put a little bit in quotes. So what we're going to do is a human can look at this picture and get a certain idea of depth. There are neural networks that can do the same thing that are quite complicated. So we're going to create a ground truth depth map. And then we're going to see if we can train a linear probe to figure out for each pixel, just looking at the internal activations, what the depth of that pixel is. Okay? So it's one probe per pixel, and together, if those probes work, what we'll have evidence of is that there is a 3D model of the scene. Okay, so what happens when we do that? And I'm just going to say, there's not time to get into details, but for those who know the system intimately and are interested, this is basically what we're doing. And I will say that we're doing two kinds of prediction, by the way. One is very simple of foreground, background. The other is based on actual depth. Okay, so what do we see from these probes? Well, this is what this stable diffusion model does. It starts out with noise and gradually turns it into a final image. So that's the output. And when we decode our depth representation, this is what we see at each step. And what becomes clear is it's coming up with a fairly detailed, coherent depth representation well before you can see details in the actual image. By the way, just as a control, if we put that noisy image into our little depth neural network, it can't figure that out. It's just like, I don't know. Similarly, if we look for salient objects, we can see it basically gets the shape of that car right very, very early on, whereas if we tried to detect a salient object using a neural network, we would not see it. Okay, we could say, okay, is it really using these representations? Maybe we've just detected something ancillary. And in fact, we can show that just as with Othello, we can intervene. We can change the internal foreground, background map and shift around and cause, like here it is drawing a purse, we can change where the purse is just by changing this representation. So there is something real going on here. Okay, so we have this internal geometric representation that we can read and manipulate. So let's go back to language models and say, what can we measure about a chatbot? So the answer is maybe we can learn to read things. And in fact, let's give you an example of what we can do.
So in our new language of sensors, right, can we, based on some of the dialogues that we were sharing before with you, can we understand things like, is there a direction inside this model for user gender, for instance? Is there a direction for user ethnicity? Is there a direction for socioeconomic status? Is the system modeling these things about us as it's talking to us, or no? And if we can find these sensors, if we can start to, get some signal from those, can we build actuators, right? Once we have these anchor points, can we actually use them to control the system? And would we want to? And for what reason, right? So let's now tell you about a little experiment that is happening, as very recently was happening in our lab. So one of the things we're very interested in is this notion of socioeconomic status. One, does the system care about that? Does it model anything about that, about me as I'm interacting? And can I get that? So one of the prompts that one of our grad students decided to use is going to Llama 2 and asking, I'll have my vacation in Hawaii. What's the best transportation method for me to get there? I live in Boston. Boston to Hawaii. Okay. And so our grad student found a direction that seemed to be meaningful in terms of socioeconomic status and put that in the middle. Okay, so middle class. So the answer was like, great choice, Hawaii is great. Yeah, I'm happy to help you. And the bot, I'm not gonna read everything, but said things like, oh, there are plenty of airlines that offer direct or connecting flights. So you can choose, there's a wide range of choices there. Like, okay, Great, perfect answer. It's true. Everything it said is true. All right, so then, because now we have this direction around socioeconomics, the grad student decided to bring it towards the lower income bracket, okay? And ask the same prompt. And the bot says, oh, unfortunately, there are no direct flights from Boston to Hawaii. But you have other options. Here are some connecting flights. That is a lie. So there are direct flights and indirect flights, but the bot decided to not reveal that information to the poor user, right? And that's interesting. That's an interesting decision on the bot's part. Once the grad student flipped it towards the other end of socioeconomic status on the rich intervention, the chatbot started talking about private jets or helicopters in many different ways, never touched on connecting flights or anything. So one of the things that I think is interesting is that apparently the chatbot is aware of a wide variety of options to answer this question, right? And it is carefully choosing how to answer that question based on this dimension of socioeconomic status. Now, this may be exactly what we want, or it may not be. It may depend on the context. Do I, as the user, care? Do I want the bot to be treating me differently depending on its understanding of my socioeconomic status, right? And so there are all these questions that start to come up. And so one of the things that we started thinking about in our lab is this notion of dashboards for AI. Up to this point, with, just interacting with these things I'm thinking back to those trains and those locomotives that had a bunch of controls that let the train go forward and backwards and stop. No gauges, no metrics of anything, right? So the question is, can we get to the point where I start to have gauges, where I start to understand what's going on internally with these systems? And I think, and one of the things that we are very interested in, and I think we're starting to get to the point where we can actually usefully think about this, is not only gauges for experts and the people building these systems, even though those are absolutely necessary, and we need more of those, but also gauges for the rest of us, for end users who are interacting with this technology day in and day out and may have no idea how these systems are modeling us, right? There's another analogy that I think is super interesting with the train. If you think about that dynamometer car, it was full of scientists. It was a very scientific undertaking to understand that powerful technology, right? But one of the things that starts to happen over time is that you take whatever gizmos or metrics or gauges that these scientists are experimenting with, and eventually some of those are going to make their way to dashboards that conductors will use day in, day out. And then once we have these metrics and these dashboards and these gauges, we start to have regulation about these things. We start to have standards about what's acceptable, what's not acceptable, right? Then we have speed limits. It's going to be hard to have speed limits if the conductor doesn't know how fast they're going. So what are our speed limits? What are the things, what are the gauges and the metrics that we care about with AI? And one of the things that Martin and I started getting really interested in is when you think about all the complex machines, again, maybe forget even a little bit about AI. When I think about my oven at home, my microwave, even my humble toaster, they have gauges, they have indicators. Even my toaster has a little light that goes up and says, I'm hot, do not touch me right now, right? I have nothing like that for my chatbot, right? Tesla cars, huge dashboard with all sorts of interesting sensors and visualizations of what the sensors are seeing and what they may not be seeing, right? Super important. We have nothing with LLMs, with large language models. Why? Why are we not instrumenting them? So one of the things is, if we could instrument, if we could create these sensors, what would we want to report on? So we believe that there are two models, internal models of these systems that we may deeply care about. One is the user model. So in other words, what does the chatbot think of me? And the other is the system model. What does the chatbot think of itself and how it's behaving right now? And maybe I want to know that as a user. So very quickly, I want to go over this notion of a user model. So this is speculation. This dashboard does not exist right now, but I hope it does soon enough. If we could, again, get those sensors around things like age, gender, education level, socioeconomic status, and maybe there are more that we care about, or maybe they're different. How can we have a little dashboard that is constantly telling me, as I'm interacting with this system, what age it thinks I am? Not because I care specifically about the age, but maybe if my kids are interacting with this chatbot, I really want it to know that it's interacting with a child, right? I do not want it to be confused about that, right? If it thinks I am less well-educated than I am, maybe it's not giving me the answers I want, right? What do I care? What are the dimensions that really matter to me as a user? And can I understand? And again, I think we're just starting to be at the point where we can actually surface these things in useful way to end users. There's another question about, and then for the system, there is this notion of identity drift for the system, where it starts being very careful and very mindful of what you want as a user, but then it starts to drift a little bit and it gets lost. Would that be interesting to understand if there's drift going on for the system, right? The attitude, is it feeling helpful towards me? Is it not feeling helpful? Is it angry at me? That would be nice for me to know. Fictionality, this sense of like, oh, we're having a conversation about facts right now. Okay, I'm on it. I will be factual. Or, ooh, now we started talking about unicorns and fiction lands and fairy tales. That's cool. I can roll with that. So I'm going to be less factual. That's okay. But if something like that happens and it flips, like it flipped the gender for me, I want a little warning sign. Oh, something just flipped for the system. Now it's in fiction land. Just wanted you to know. Maybe that's great. Maybe it's not so great. You as the user can decide what is useful and what is safe, right? And then the last thing about this, a couple of things. One is, could we have something like this in context as I'm interacting with the system and I'm seeing it evolve and giving me little warn signs? And then the last thing that this mock does not show, but I think would be wonderful, is how do we go from these sensors to actuators? Again, now that I have hopefully these anchors and these dimensions, I want to control them, right? So I want to say, now bot, you are in child mode because you're interacting with my daughter, right? That matters for me. Or I want you to really not care about my socioeconomic status, or maybe I do deeply, but I am in control of that, right? So I think these notions of understanding what's going inside and bringing these gauges and metrics outside can be really powerful things.
Okay. So what does this come down to? How can we help people use AI? So we have these noisy, unreliable sensors that you're seeing, these linear probes that will extract sort of, one dimension at a time of information from our systems. We have these powerful systems that may well become pervasive. And how do we help with this? What expertise do we need for this? We need people who have experience turning sensor data into actual sensible data, raw data into something you can use. People who have deep expertise in understanding how you can control complex socio-technical systems, interfaces showing the data in the immediate context. what field might possibly be able to help? Well, you, of course. This is why we are so delighted to be here talking to you, is we feel like there is this grand analogy between what the UbiComp field has been studying for decades and what we as humans have to do with AI. You know, if you think about it, the kinds of sensors that are sort of the backbone of so many classic UbiComp systems are, I don't know, motion sensors or heat sensors that are actually trying to get at the complexity of human activity inside of a building. This idea of taking these one dimension or very sort of finding a key feature that then you can use and display, all critical. So we feel like you are a key to the way AI can be used better in the future. And so we're just going to say very generally we need your help. And very specifically, I will also say our lab is looking for students next year who are excited about turning interpretable AI into usable AI. So with that, I'll end there, and I believe there's a little bit of time for questions. Thank you very much again.
There you go. Wow, thank you so much for this amazing talk and sharing these rich ideas with us. Well, let's open up for questions. I don't think we have a whole lot of time because, as you heard, we need to reconfigure the room at some point here fairly soon. But I will just pass the microphone and we'll get to it. Oh, well, I'm here now.
Judy Cave, Sydney Uni. This made me think of the area of artificial intelligence. Let's try it again. AI Ed, artificial intelligence in education, hard to say. It's a parallel universe to this one, and it has long been building systems that have lots of AI, have lots of sensors of learning with lots of noise in the learning, because God knows who was really using the computer and whether they were getting help and a million things. And it came up with the idea of an open learner model where you design something which is very much like the pictures you had, in order to enable a learner to see what the system thinks about them, anthropomorphizing. And what is important about that area is two key things that I'd love your thoughts on. The first is that it's designed for a purpose. So in the case of a learning system, kid learning maths, you want them to learn the maths. And there's a whole area of metacognition and awareness of your own knowledge and so on, which maps to this, I think. But the second is that as soon as even something as simple as your interface turns up, how do you make it so people really understand what the designers thought they were designing? And so how do you perhaps scaffold the use of that in a way that's meaningful? I'd love to hear your thoughts, because you've clearly been doing a lot of cool studies in the same sort of general direction.
That's great, thank you. So yeah, I think there's so many questions around the potential design of something like a dashboard. And I think to your point, my sense is that it's going to be very context-based and domain-based. So a dashboard for education, and I thought specifically about education, I think it's going to have to be very different than a dashboard for, say, someone who is looking for travel advice. Part of the thing that I was wondering, I think along the same lines of what you brought up, is this notion of how much transparency do we want for the learner? Because I think the learner is in a very vulnerable position. So even though the system may understand that the learner is very, very novice, do we want the system to be constantly saying, you're a novice learner, you're a beginner, you're a beginner, you're a beginner? Or is that something that we show to the teacher's dashboard, so that the teacher has a different level of transparency than the student? So I'm thinking these are different users with different dashboards. We don't know. But I think one of the things that I think is, if this is one of the ways that we end up going, I think we're going to need tons of user testing. And to understand what are the dimensions that are helpful, what are the dimensions that get in the way and are not useful at all. And I think education is going to be one of those cases that maybe we have different kinds of dashboards, multiple dashboards depending on, are you a student? Are you a parent? Are you a teacher? So many, many unknowns right now.
Great, thank you.
So I really like this example you had with this providing some sort of a liberal background and getting different thing on government. But I would like to challenge your assumption that a system does any sort of modeling on adaptation, right? The whole thing is a token prediction system. Based on a history of tokens presented, it gives you the most likely token. So, adaptation, as we understand, is a UbiComp presents as, creating something that models the user. So the question is, in terms of transparency, rather than this dashboard allowing it to change adaptation, shouldn't you just tell the user that the system doesn't answer the question? All it does is, given what you give it in text, it tells you what's the most likely thing you would find on the internet related to that. So again, I find it really strange to say it's modeling or adapting. It isn't.
Yeah, so I think you're getting at sort of a major area of controversy and confusion right now, which is that these systems are trained as next word predictors, and it feels like, intuitively, they're just a collection of statistical associations. And in some sense, that is true. However, there's increasing evidence, and some of the projects we showed are sort of describing this, that the best way to understand the mechanisms behind that prediction is not just to say, it's a huge collection of statistics. Like, that's just genuinely not always a helpful way to look at it. Whereas, if you do look at these internal representations, that can tell you useful things. And the sort of proof that it's not just an illusion is the fact that you can intervene and control it using those things. So I will acknowledge that there's a major controversy here, but part of the point of going into the technical detail was exactly to sort of complicate this idea that next token prediction is some simpler, trivial task. I think a good way to look at it is it's actually very hard, and the only way that something can actually predict can get very low error may turn out to be it develops internal models. That said, it is definitely an area of active research, and I think the other thing I would say is it seems very likely that the right point of view on this is that a large language model has models of some things, and then sort of a collection of hard-to-understand statistics it's also using. That there's basically a balance between what people sometimes talk about as generalization and memorization, which is one of the very complicated aspects of this. You can certainly find cases where it appears to be memorizing stuff, but that doesn't mean it isn't generalizing in other important cases. So
I was not implying that it's memorizing. The statistics is not about memorizing, but it's a controversy. I agree.
Yeah.
Okay, just one final question.
Hi, thank you very much. So I'm Sarah Bouchnac from INSA Lyon in France. Great talk, very interesting. Interestingly, you talked about the sensors, how to provide the sensors to model, to capture the behavior of the user or to better describe the system. And at the same time, actuators that would help us make the model, change the model. Do you have an idea of novel actuators that could help in handling, open issues like, biased models or questions like this? Do we have clear views or examples of such actuators in the models?
So this is an active area of research. Lots of people looking at bias in AI and generative AI models. I think there are techniques and approaches that we know already today that help with alleviating some of the effects that you can get from, say, biased training data or different kinds of ways that these systems behave. There isn't anything that fixes the problem, that there is no silver bullet, but one of the things that I think our hope is that if we can surface to the end user some of these skews, some of the ways in which the system may be skewing a certain way or another. That one, for awareness, this would be helpful. And then again, if I, as the user, can then control that to get rid of some of the side effects, that could be one of the ways in which we start to address some of the problems. Now, I will also say, again, I think questions around bias and skews can also be very domain specific, so that's why I don't think that any general technical answer is going to solve it all. I think it's going to be something that we do both on the technical side, so approaches that continue to address some of these inequalities, but then on the end user, I really think the end user needs to have one, transparency and control.